Okay, so another thing that can influence the rate of neurotransmitter release, even though the action potential is all or none, are presynaptic effects. So, for the most part, when we talk about neural communication and like general psychology, we talk about axodendritic communications, right? So, here is your presynaptic cell. It is synapsing onto the dendrite of a postsynaptic cell. And so, it is an axodendritic synapse. And that's fairly typical, right? And that's usually what we talk about. You should also know that axons can synapse onto the cell body, right? So there are receptors on the cell body as well. So you can call that an axosomatic synapse. But a key thing that will be important for what we're going to talk about in this class is what we call an axoexonic presynaptic effect. So here you have a postsynaptic cell. You have a presynaptic cell that is trying to synapse onto the body of the postsynaptic cell. And then you have another cell that is coming in and it is synapsing on the axon of this presynaptic cell, right? And so you can have an effect not just at the level of the cell body and the dendrites, but you can have an effect at the level of the axon. So let's zoom in and look at the two different types of effects that you can have. All right, so one effect that you can have is something that we call presynaptic inhibition. So if this presynaptic cell is trying to synapse onto a postsynaptic cell, then what is happening is that a third cell is coming in, and that third cell is, in this case, releasing GABA, right? And we know that GABA is inhibitory. So if this cell is having an excitatory or an action potential, right, it's about to release a neurotransmitter. And this doesn't say what neurotransmitter it is. So let's just say it's trying to release GABA, right? So, or sorry, glutamate. So the action potential has happened. The action potential has regenerated down the length of the axon. It gets to this presynaptic terminal. It opens these calcium channels. Calcium is supposed to come in to induce exocytosis. But meanwhile, this presynaptic cell B is releasing GABA directly influencing this presynaptic terminal. GABA is shutting it down, right? GABA saying, I know that the action potential, right, like depolarized you to open these voltage gated channels, but I'm going to come in, I'm going to inactivate those channels. That means that calcium can't come in. And if less calcium comes into the cell, then less neurotransmitter is going to be released. So that is going to reduce the impact, right? Reduce the amount of neurotransmitter. Even though this cell was all ready to do it, right? That's going to reduce. And so that's going to reduce the effect on the postsynaptic cell. You could also have the opposite, right? You could have presynaptic facilitation. So, presynaptic facilitation, we have presynaptic cell A, right, that is going to release, let's again just say glutamate for the sake of what we're talking about, that's going to interact with the postsynaptic cell. And then you could have presynaptic cell B releasing something like serotonin. And in this case, serotonin, and remember, serotonin we said is a weird one because serotonin sometimes is inhibitory, sometimes is excitatory. So in this example, what serotonin is doing is it is helping to activate the calcium channels. Calcium channels are already opening, right, because of the depolarization from the action potential, but serotonin is increasing that. And serotonin is then going to allow more calcium to come in, and more calcium comes in, more neurotransmitters are released, right? So the effect of that pre or postsynaptic inhibition, or sorry, presynaptic inhibition or facilitation is going to directly impact how many of those neurotransmitters are released. And in this Prezi, I posted a video, again, because I'm recording in Prezi, it's not allowing me to play these videos, but if you are not understanding this, right, if this is a concept that you're not feeling familiar with, go in and watch this video because this video is so helpful in visually showing you. It's going to take you through a couple of like temporal and spatial summation examples, but specifically, I put the time here. Let's see, 2:30 to the end. You're going to see very clear examples of this presynaptic effects that we were talking about to help you to understand them.